Okay, so here's one of the questions that came up in the homework. We've got two particles being launched from different positions. So let's put the ground in, and then we'll put one in that's 50 meters above the ground. So this is 50 meters above the ground. This is the ground. Okay, so this is point A, and one particle is launched with a speed of 2 meters per second. As you can imagine, it doesn't go much higher than that, but starts to fall. This is point B. Another particle is launched from there, and that's launched with 20 meters per second, so it's going to rise much more quickly. We want to find the point where they're in the same position. So I want to find T, big T, where they meet, and I want to know the height of that position. Okay, so now, as you can imagine, they're starting from two different points which are 50 meters apart. Now, we did questions like this before when one object was being thrown down and one object was being thrown up. So what we'll do for the first object, we're going to basically assume that it's falling. As basically it's 2 meters per second, so it means it's not going to go much higher. It's going to start to fall towards the ground, so that makes sense. So its displacement is going to be minus 2t, because we're going down. Remember, it's being projected upwards initially, plus 1/2 times gravity times t squared. Okay, so remember, gravity is positive, as we're assuming the downward direction is positive. Now, the other particle we're going to assume is going up. So s, this time our initial velocity is positive. But now our gravity is negative. Okay, so if one's going down and one's going up, at some point they're going to be at the same height. So now what we want to do is combine those two together. Now we have to take into account the fact that they are initially 50 meters apart. So this is why we do one up and one down. So we're going to take S to be 50, and that's basically, let's say they meet in the middle. This one will be 25 and this one will be 25. If they meet 4/5 of the way up, this one will be 10, this one will be 40, but either way, the total can't be more than 50. So now we're going to add these two together to get our total of 50. So I've got minus 2, and I'm going to write the t now as big T, because that's what I want. Now that's plus 1/2 g times big T squared. And then I'm going to put my second equation, which is plus 20t, and then that's minus 1/2 g times t squared. Okay, so now I've added, this is my equation 1, my equation 2. I've written equation 1 plus equation 2. So now you can see that I've got 1/2 g times t squared and 1/2 g minus 1/2 g t squared. So these two cancel out. So now my total of 50 is equal to 2 minus 2t plus 20t. So that gives me 18t. So my t value is 50 over 18, which is about 2.8 seconds. Okay, so remember, what did we do? We took the total. Okay, so the total distance was 50 meters, and equation 1 plus equation 2 gave me the total for both balls, one going down and one going up. Okay, I hope that makes sense.